In this example, we're going to graph a hyperbola that is not centered at the origin. Let's identify the center of this hyperbola to be 4, -2. We get the x-coordinate by looking at the x factor here. We get the y-coordinate by looking at the y factor there. Let's put a little x at 4, -2 to indicate the center of the hyperbola. Now we need to identify whether the hyperbola whether it opens horizontally or vertically. Because the x's are to the left of the minus, it's going to open horizontally. To convince yourself of that, we could look at the hyperbola that's not shifted. So we could boil it down to just the essentials. We could take out the center 4, -2. And this hyperbola would have x-intercepts and no y-intercepts. Because if we plug in y equals 0, we would get x equal ±3. If we plug in x equals 0, we would get y squared equals -16, which has no solution. So we would have x-intercepts, so this tells us that we open horizontally. Open left and right. Okay, so let's go ahead and find the fundamental rectangle. So the fundamental rectangle is found by looking under the x's. We have a 9. The square root of 9 is 3, so we're going to go right and left 3. And these points are on the graph because this hyperbola opens horizontally. Now let's look under the y's. We see a 16, so we're going to go up and down 4 from the center. I'm going to put little x's, though, because these points are not on the graph of the hyperbola. They are just used to build this fundamental rectangle. So let's draw the fundamental rectangle. And the fundamental rectangle guides us in graphing the two arches of the hyperbola. So we're going to connect the opposing opposing vertices. And when we connect the opposing vertices, we are going to get the asymptotes. Oh, shucks. Let's get to a line. So we are going to get the asymptotes for the graph. And the graph of the hyperbola must go through these two vertices, and it must approach these asymptotes. So here is the first arch. Here's the second arch. And that is roughly what our hyperbola will look like. The next step is to find the foci. The foci are found by looking at c, little c. And the equation we use is that c squared is equal to the sum of the denominators. And then we take the positive square root so that we get c to be +5. That means from the center, we're going to move 5 units, and we're going to go inside the arches of the hyperbola. So and usually I would put little x's just because these are points that are not on the graph. So then 3, 4, 5. So those are our foci. Focus 1 and focus 2. And the foci are ordered pairs. So we could write them like this. We could say that the coordinates for the foci, the x-coordinates will be 4 ± 3 whoops, I said that incorrectly. It should be 4 ± 5. Sorry about that. All right, c is 5. So we go to the center, the x value of the center, and we're going to move 5 to the right and 5 to the left. So we take the x-coordinate of the center, and we add and subtract the c value. And then the y value for both foci is -2. So we could actually find these ordered pairs pretty easily by adding the 5 and subtracting the 5. Sometimes you won't be able to do this because you have a square root. You end up with 2 terms here that you cannot combine. In this case, we can. So those are the coordinates of our foci. Now we need to find the asymptotes. The asymptotes are a little bit trickier. And what we're going to do is look at the y factor up here, y plus 2, and we're going to basically write slope-intercept form with a modification. We're going to put y plus 2 equals, and then we're going to do rise over run. So here's the rise, here's the run. The rise is going to be the square root of the number under the y expression. The run is going to be the square root of the number under the x expression. So rise over run is going to be 4/3. And we need to put a plus or minus in front of it. And then the x expression. The x expression is x minus 4. So these are the equations of the asymptotes. And most of the time, we will leave the equations of the asymptotes just like this. We won't multiply it out and put them in slope-intercept form. This kind of indicates that the center of our hyperbola, the intersection of the two asymptotes is at 4, -2, and this tells us the slopes. Kaboom!